In this video we will discuss the requirements for a disconnecting means at a pool pump house, specifically addressing compliance with the National Electrical Code, or NEC. Often, structures such as pump houses are supplied with electrical power from a main building, and it's crucial to understand how to properly disconnect that power locally for safety and maintenance. Firstly, addressing the question of whether there should be a disconnecting means at the pump house, the answer is yes. The National Electrical Code mandates that a disconnecting means be provided at the pump house. This is primarily for safety reasons, allowing for quick and easy disconnection of power to the equipment during maintenance or in emergency situations. The code requires this to ensure that anyone working on the electrical equipment within the pump house can energize the circuits locally, preventing accidental electrical shock. Secondly, there are no exceptions, or what was referred to as a gimme, in the NEC that would waive the requirement for a disconnecting means at pool equipment buildings. The code is very specific about the need for a local disconnect to ensure safety. All pool equipment buildings must adhere to the requirements outlined in the NEC, which includes having a readily accessible disconnecting means. Thirdly, the breaker at the clubhouse does not act as the disconnecting means for the pump house. The disconnecting means must be located at the pump house, close to the equipment it serves. This ensures that it can be easily accessed to disconnect power from the equipment. Having to go back to the main building to disconnect power is not considered a safe or practical solution. Now, let's discuss corrective actions to comply with the NEC, specifically addressing the absence of a disconnecting means at the pump house. Since the existing installation has a 100 amp breaker in the clubhouse feeding the pump house with number 8 American wire gauge or AUG THW conductors, and there is no disconnect at the pump house, the following options can be considered. Option 1 involves installing a separate 100 amp disconnect switch at the pump house. The existing number 8 AWG THW 4-wire cable from the clubhouse panel should be connected to this disconnect switch. Then, the 100 amp panel at the pump house is connected to the load side of this disconnect switch. This option provides a clear and compliant method of disconnecting power at the pump house. Option 2 involves replacing the existing 100 amp breaker in the clubhouse panel with a 100 amp circuit breaker that has a built-in disconnect switch. This type of breaker allows for local disconnection at the panel itself. The number 8 AWG THW 4-wire cable from the clubhouse panel would then be connected to this circuit breaker with the built-in disconnect switch. Additionally, a cover should be installed over the circuit breaker to prevent accidental operation. This approach centralizes the disconnect function at the panel, but it's essential to ensure that it meets the requirements for accessibility and visibility, as outlined in the NEC. Furthermore, it's important to address the fact that the number 8 AWG conductors are carrying 67 amps, which exceeds their allowable ampacity according to the NEC. Number 8 AWG THW copper conductors typically have an ampacity of 50 amps when installed in a raceway cable, as per NEC Table 310.16. This means the existing installation is not compliant with the code and could pose a safety hazard due to potential overheating of the conductors. To rectify this situation, there are several options. Firstly, the load on the circuit could be reduced to ensure that the current does not exceed the ampacity of the number 8 AWG conductors. This would involve carefully assessing the equipment connected to the circuit and determining if any of it can be removed or rewired to other circuits. Secondly, the existing number 8 AWG conductors could be replaced with conductors of a larger size that are suitable for the load. For example, number 6 AWG THW copper conductors have an ampacity of 65 amps, which would be sufficient for a 67 amp load, provided that the installation conditions do not require dirting. Thirdly, if the load requirements are expected to increase in the future, it would be prudent to install conductors with an even higher ampacity. For instance, number 4 AWG THW copper conductors have an ampacity of 70 amps. Remember to calculate voltage drop. The distance between the clubhouse and the pump house is 150 feet. This distance can lead to voltage drop, which can affect the performance and lifespan of electrical equipment. It's crucial to calculate the voltage drop to ensure that it remains within acceptable limits, as recommended by the NEC. The NEC recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using the following formula. Voltage drop equals 2 times the length of the conductor in feet times the current in amps times the impedance of the conductor per foot divided by the conductor's circular mil area. The impedance of the conductor depends on the material and temperature. You can find these values in the NEC or electrical engineering handbooks. To mitigate voltage drop, consider the following measures. Firstly, increase the conductor size to reduce the resistance and, therefore, the voltage drop. Secondly, use conductors with lower resistance materials such as copper instead of aluminum. Thirdly, reduce the length of the circuit by relocating the power source closer to the load if possible. Furthermore, ensure proper overcurrent protection to protect the conductors and equipment from overloads and short circuits. The overcurrent protection device such as a circuit breaker or fuse should be sized according to the ampacity of the conductors and the rating of the equipment. The NEC provides guidelines for selecting the appropriate overcurrent protection device. Also, ensure proper grounding and bonding to provide a low impedance path for fault currents. This helps to minimize the risk of electric shock and equipment damage. Grounding and bonding should be done in accordance with the NEC requirements. Finally, use appropriate wiring methods and materials suitable for the environment in which they are installed. For example, if the wiring is exposed to moisture or corrosive elements, use conductors and raceways that are rated for wet locations. In summary, firstly, a disconnecting means is required at the pump house to ensure safety during maintenance and emergencies. Secondly, there are no exceptions in the NEC that waive this requirement for pool equipment buildings. Thirdly, the breaker in the clubhouse cannot serve as the disconnecting means for the pump house. Additionally, the existing number 8 AWG conductors are undersized for the load and must be addressed by reducing the load, increasing the conductor size, or both. Ensure that voltage drop calculations are performed and that appropriate measures are taken to mitigate voltage drop. Also, proper overcurrent protection, grounding, and bonding are essential for electrical safety and compliance.